Hello everyone, we're happy here to tell you more about how you can improve your CI performance with Maven and Gradle build on CI. Right, so with me today is Arnaud from CloudBees. Do you want to introduce yourself briefly?
Thanks, Etienne. This is Arnaud. I'm manager at CloudBees in the support team. I am leading all the tooling efforts of the support team. And personally, I am working in IT for 20 years, not far. I am a contributor of Apache Maven for more than 15 years. Or at least now I am more following that I am doing things, but I know very well the Apache Maven and Jenkins also. I am using it for more than a decade. Yes, I joined CloudBees 4 years ago, and I like all the automations, processes that we can do in the developer, with the developers and so on. So that's why I'm here today.
Great. Thank you for coming all the way from France to do this webinar.
Thank you.
My name is Etienne. I'm a VP of Engineering at Gradle, and my main focus is on Gradle Enterprise, which is also going to be touched on today. All right, so to get started, we want to give you a brief introduction of what Gradle Enterprise is, but also what CloudBees Suite is, of course. So, want to tell us more about that?
Those CloudBees, our company is focusing on CI/CD environments, how to automate and simplify the usage of these automations that we can put in place in various companies. The origin of the company is centric on Jenkins, and centralized on Jenkins. We are supporting Jenkins, we are providing support for customers using Jenkins, classical versions, open source, but we have products built on it. So we will see today CloudBees Core, which is built on top of Jenkins, which is one of our products. We have more products today in our side to ease the deployment and the whole chain of management of the automation, the monitoring of this automation, and those we will see a bit DevOps today, but we have other tools also to simplify the management globally of your CI/CD environment.
Great, thank you very much. So I look forward to see more details on that, and we're going to do quite a few demos, right? So we'll show these tools in action. So before we go on, we would be curious to understand what CI tool, CI server are you using in your project? So if you want to fill out the poll really quickly, then that would be of high interest to us. Arnaud, we already know you're using Jenkins.
Yeah, but I use in fact a lot of them because in the past I was consultant in France, and for various customers, I had the opportunity to use Bamboo, to use JetBrains product and so on. All these products are certainly different in how they are approaching the need of CI/CD, but we are following the same goal: how to help the developers to be efficient, how to automate the things in the whole chain. We are starting from the developer side, where we are building an application, and then how to make it accessible to the end users, all the steps together.
Okay, great. And maybe just for what we are using at Gradle, we are using TeamCity, so JetBrains product. Yeah, which we're also very happy with. But today we'll find out more about how Jenkins and Gradle Enterprise can work together. Right. So we got the results of the poll. So we have 81% of the audience here is using Jenkins, 6% are using TeamCity, 6% are using Bamboo. We have 2% with Circle CI, and we also have 21% that are using something else. What that is, we can see in the message channel, but I think for now I'll just move on with what we want to share. All right, so I'd also like to give a short introduction of Gradle Enterprise. But before I do that, it's important to understand what is the difference between a Gradle build tool and Gradle Enterprise. Right, so Gradle build tool is an open source project. It gives you the build automation. It is for free. Right, it's used a lot. We have like 11 million downloads by now. And also by now there are more projects on GitHub that are using Gradle than Maven, since just for a few months now. This has swapped. But then we also have Gradle Enterprise. That's the commercial product. You install it on premises, so it's running within the safety of your network. And its focus is to increase the development productivity, which also aligns very much with what you at CloudBees and with Jenkins and CloudBees cores are doing, is really making developers more productive, or whole engineering teams more productive. Right. We did a lot of consulting, like you did as well, and we saw some recurring themes over the years, and that is really people, they have slow builds, they want to make their builds fast, and they want to keep them fast, right? And it really amounts directly to money that you're saving. Also reliability, you called it, like high quality builds or high quality feedback. We see that a lot, that the reliability is low, people don't know what's going on, and without that they lose trust in the build, they lose trust in their environment, in the CI tools and so on. And the third one is related to that, it's the debugging. If there's a problem, you want to solve it quickly so you can move on. Right? But often the practices or the reality is different, right? If something comes up, it's not related to the code you're working on, but then suddenly you're spending hours, maybe even days sometimes, to find out what the problem is. And it might not even be related to your change, or typically is not. Right. And so with these recurring themes that we found in all the projects, we built Gradle Enterprise about 4 years ago. And we've had webinars about that before as well. So I just want to keep it really short here, give you a rough overview. Basically, like I said, you install it on premises, and then you connect all your builds to it. Whether it's a Maven build or it's a Gradle build, doesn't matter to Gradle Enterprise. And connecting means you add a plugin or an extension to your build. It's very non-invasive. You point to the server, and that's it. What then happens is it starts capturing data about your build. Because we will see, right, we need the data to understand what's going on, to improve things, and to measure again whether that change we did was successful. And then we can also accelerate the build, and the acceleration comes through build caching, and we'll learn more about that as well. But the underlying idea is, let's not do work that we've done before. Right? And all these things, and I think that's important, even though we focus on CI today, Gradle Enterprise also applies to developers. So every time you run a local build, you get a build scan. And if you run a local build, you can also benefit from the cache. All right, so that's in really short what is Gradle Enterprise. It's over the years become a very successful product with many customers. That's just an extraction of them, but yeah, you might recognize quite a few names on here. All right, so let's do another poll here. So what build tool are you using? We would be curious to understand that as well. So I think this one is, at least for me, it's an easy one. We're using Gradle exclusively.
At CloudBees, we use mainly Maven. We still use Maven, yes. But our customers are using both regularly. We see, right. But we see Hunt is still there, and yeah, there are a lot of projects, and all the others ecosystem, because for sure we will discuss a lot today about Java ecosystems, with Gradle, Maven, and Java ecosystems, but CI/CD is involving a lot of other technologies, and you can touch so many, doing mobile stuff yes. With Android, Kotlin, and so on. But you can
JavaScript development.
Yeah, you can do Xcode and for the iOS side, and yep. Many things. Yeah.
And that's also something we see in the project. That's actually why we support Maven. Initially, we only had support for Gradle and Gradle Enterprise. But we realize many projects are still using Maven, yeah. And they don't even want to switch. Mm-hmm. And that is fair, right? If you don't have the resources, or you want to invest the resources in building new features, yes. Versus migrating an old build that you're happy enough with, then so that's the reality. And there are other things, like you said, like the NPM ecosystem, the Xcode, and so on.
There are so many.
And there's more we want to support as well in Gradle Enterprise, right? Other build tools. So we have the results of the poll. So we have 79% that are using Gradle. We have 40% using Maven. So this is more than 100%, but that's because we allow you to select multiple options. Right. We have 16% using Ant. Right. So like you said, Ant is still there, and probably will always be there.
Oh yes.
And then we have 14% using another build tool. Again, we will see that in the message channel what those are, but I will skip over those for now, not in a disrespectful way, but just so we can proceed with what we want to show you here. we talked about this at length the last few days while we were preparing is, well, what engineering organizations, almost all of them are facing today is low productivity, right? And it has several causes, right? One is when it comes to root cause failure analysis and the resolution, it's very inefficient. If you don't have any insights, what's going on, it's really problematic to solve the problem.
It's complex, and worst of all the time when the problem is staying for a long time. So
Yes, so that is definitely, and also oftentimes situation is you have a problem, you try to understand it, but to understand it you need to reproduce it, and then it doesn't happen anymore, and now it gets even worse, right? And in the end you don't work on the features you're supposed to. And then also slow and unreliable feedback, right? Which really makes it hard for you to verify your changes, get them deployed to development environments or staging environments, and so on. Right. And the third one, and that I find that quite interesting as well, is in general there's quite a bit of lack of knowledge of how software is built in organizations. So you ask them how many developers you have. Larger organizations might not be able to answer that question. How many people are contributing to that repository? Or you ask them, are your developers running the tests locally? Or what Maven version are they on? They might all say, well, we're using version X, but then you check and you realize, oh, they have a whole slew of different Maven versions, right? So there's just in general lack of knowledge of how software is built. And we'll see how we can address that. And again, we talked about CI, or is the focus today, but all the things listed here are also applying to building locally as well, right? And it's definitely an interesting angle because that's where the CI cannot help you, right? It's the what happens on your local machine. Right? All right, so we'll one last thing to set the theme, which is a bit of a dark theme, but it's just the reality in many companies today before they start using the right tools. It's just some quotes, right, from customers that are pretty frustrated. Engineers, developers, build masters, managers. So I don't want to rephrase them all here, but they're all actual messages. I think the last one is pretty interesting in that, we see that a lot too is the threshold of pain is very high. It's so high that at some point people just get used to the pain. It's like, okay, 50 minutes build time. That's okay. I'll just get a few more coffees.
Yeah, the famous XK CD where they are playing. But this is a problem. If you don't put your expectation at a level which is what people are forgetting, that they should be efficient and they should have a quick feedback, they should build their project quickly and so on. And yes, considering that your build is taking 50 minutes is normal. No, it's probably not the default build, at least, of your project.
Yes, I agree. Yeah, but I think we cannot blame these people because that is typically, builds take a long time today because of the complexity and if you don't use the right tools and so on, or any tools at all. So it's just what you're used to from this whole ecosystem.
And you have to take the time to work on this topic and to really adapt your processes, adapt the tooling you are using and so on, to be sure that you are efficient, because it will help you every day and it will help also the delivery chain to deliver more frequently your releases and so on and so on. So,
And then there's another one here with the 8% where the checkout hangs. You brought that up a few times when we discussed this. It's like CI gets blamed for a lot of things, just like the build.
This is the basic stuff. But when myself working on support, we are seeing a lot of things, and the CI is in the middle of everything. So for sure, as soon as it is broken, as soon as something is not going like it should, it could be the CI fault, but not always. Not always. It's an ecosystem. It's not just a CI or CD tool. You have an ecosystem of a lot of softwares, and it is what you do with them. Thus, it's not by adding one tool, it's not by adding Gradle tomorrow in your company or CloudBees core that you will solve your problem. You will have to set up all these tools correctly, all together working well, and to also work with other people, work with the teams to adapt the right methodologies which will help you to progress and improve your developments. Thus, that's easy to say, okay, this is a problem of Jenkins is failing, and Jenkins is like, yes, but when you have, for example, a Git repository of several gigabytes, okay, we can blame Jenkins, it's so slow to check out the project. but is it the real root cause of the issue? Does it make sense? Sometimes it could make sense. There are reasons where you have large Git repository and so on, but does it make sense? Does it make sense to check out everything with the wallet? So a lot of questions to ask, and it's easy to blame the tool, while it's not the one tool, but these are also the processes and how you are using them, which could be the things to improve.
Right, so we try to identify like what are common CI setups. You see them from helping customers with their Jenkins. We see them from helping make their builds faster. But there's a lot of overlap. But not surprisingly, because we have also the same customers or the same audience, you could say. Right. So definitely slow and unreliable builds and build pipelines is something we see. And some things we narrowed down here is there's a little trust that builds leave nothing behind, right? So when you run them again, you have to first clean up what the previous one didn't clean up, and then start, which comes with all kinds of implications, as we will see. Right. Also, parallelization oftentimes doesn't happen on any level, not on the build level, not on the pipeline level, as a consequence, if you cannot run things in parallel, obviously you run them sequentially, and that is a big penalty you pay each time. And then people try to mitigate that problem, and what do they do? Because there is not much left to do, is they start to try and share resources. But oftentimes these resources are not meant to be shared, right? Which can lead to very nasty setups or problems, I should say. The setup is not nasty, but the problem. The other part is the slow environments, where we see people try to save money, right? In the end, and they save on like disk I/O. They save
disk
on
space. Oh, I don't want to duplicate my Maven local repository because it's taking gigabytes. But there are so many impacts. We see that later. So, hardware technically is cheap compared to the human cost and the time we can spend on just doing the things right. And those,
networking as well. Slow network access to get access to the resources you need to pull in. Also, external components being slowly, because today when you build software, you typically interact with other binary repositories, with version control systems, or you connect it to a database or some other test resource. And if those things are slow, well, everything in your pipeline is going to be slow. And also, you brought that up, that's definitely a more CI-centric perspective, is very rigid setup of agents. It's very statically allocated, so it's really hard to react to waves of lots of builds or less builds and so on. All right, so tell us a few more patterns or anti-patterns that you see in the Jenkins world.
This is what we see regularly when we interview Jenkins users, who's myself part of the community for years, and we worked on consulting also. You have different approaches to try to scale Jenkins. Either you are in a large company, you will try to deploy small Jenkins instances in your different departments, different locations, and so on. Those for sure, if they are staying small and so on, it's okay, they will be managed locally and so on, but you don't have a global control. Those Jenkins instances are not at the same version, they are not doing the same thing, they are not reusing the same patterns, you are not sharing any code because maybe you are not using pipelines, you don't have the shared libraries or these kind of things. You are duplicating a lot of things locally in all their teams, and those the maintenance cost of all of them, because you have to maintain all these instances, and it has a cost. The other approach we see otherwise is, I am a big company, and thus I will just put a big hardware, a big environment, a big Jenkins instance, and everyone will use it. Problems are different. For sure, you have only one instance to manage. It should be better, easier, less administration, less you upgrade only it once. But the problem is that you have all your projects, all your teams using it. You will have the problem of scalability of this instance, how you manage all the needs in terms of resources of the instance, how you manage conflicts, how you manage this team wants to use this version of a plugin or this version of Jenkins and not this, because of various reasons. It makes the stuff difficult to maintain too, because it's big, but you lose your ability to adapt it for the needs of the people who are using it. Thus, yes, you are centralizing your cost, but you have a single point of failure in general, and it's difficult to have an efficient service that you provide to everyone in your company.
I noticed that too, especially with like plugins. If we go to certain companies with such a, what you call here, Jenkins style approach, as we ask them to integrate a plugin, for example, the Gradle Jenkins plugin, and they're very reluctant to do this because they're saying, well, we're not sure what the impact is. Well, they know the impact could be big because it's a lot of projects that are relying on that instance. So every change becomes more risky. It affects more
because
more
you are impacting a lot of your developers, and nowadays this kind of systems. We are talking a lot about Jenkins today, but it's the same with other CI/CD tools. But if you touch them and you break them, this is the company which is stopping. You cannot deliver in production your application, your new marketing website, whatever. This is really at the heart, centrally managing everything for your company. You take a risk to not have something that you can scale, that you can really manage efficiently. And for sure, you need to centralize, because if you put everything in standalone mode in your locations, you have a lot of time that you spend to maintain them.
Yep.
Right trade-off.
So there's probably a golden middle here somewhere.
Yeah,
right?
Something like this, yes.
Let's see. All right. So,
in terms of architecture, this is what we see in this kind of customers. A mix, a bit of them. But in general, we have big instances, smaller instances managed by some teams who are happy enough to manage their server, but they are attaching some resources, some agents, those in Jenkins terminology, to run their build. These agents are generally not shared, at least outside of this Jenkins instance. So there is also a problem of cost of all of this. You have the problem of cost in terms of human cost to maintain, to keep running all this environment, but you have the cost in terms of hardware that you are using that you cannot reuse, because for sure in CI/CD the needs are evolving over the time. You have projects who will need a lot of resources one day and the other one will be the week after, and so on. It's evolving. So it's always the same problem. If you isolate completely your teams and their needs, you cannot rationalize your cost. Thus you need to find the way to correctly adapt your infrastructure based on the need of everyone, and to be sure that you have the required resources when they need it. Because what we are saying, you need a quick feedback. What is important is the reliability of the result and a quick feedback. You want something in which you believe in, and it should be quick.
Right. And oftentimes, I mean, we're not trying to kind of blame people here. So these things are done for reasons given by certain constraints within their operating. Right. So it's so let's see that in practice. Well, it's a simple setup. But let's see a setup that you often encounter when you help people with setting up an ideal CI.
So yes, today we will show some examples. We took some projects which are well known in the Java ecosystem. We took a Spring Boot and a Spring Framework. So these are really different kind of projects. Spring Framework, it's an injection framework. It's a very small, doing specific things. It's really a tool set, limited tool set for this need. While a Spring Boot, it's a big project integrating all the Spring ecosystem, and those they have a lot of needs in terms of resources, in terms of tests, and so on. Those I reproduced what we see and what we have in general in terms of CI setup with Jenkins. Those we will see later what CloudBees Core is helping for or not, but for now we'll consider that we have a classical Jenkins instance.
Maybe it's worth to highlight that this is not how the Spring Boot has set up their build.
Not at all.
We set up our own
pipeline. It's really a setup which was done on our side.
Using their project.
They are using Concurs, I think, on their side, but it's just and they are not doing anything wrong. It's just that we try to demonstrate on a real project what could be the pitfall and the problems of having a classical Jenkins infrastructure, and thus we try to have this kind of environment here. Thus, when you have a CI/CD environment, what you try to do firstly is to have some agent to execute your builds, and to allocate these resources in general. Thus, you put a server in place somewhere. Thus, it could be a virtual machine, it could be a bare metal server, it could be various things, and you put in it what we call executors with the ability to run different builds on this machine for this given agent. Thus, if we try to build those, for all our tests in Spring Boot, we took the version 2.1.x just to have an idea of something that is possible in terms of setup and what is good or wrong, and we will see how to improve that. But in a classical approach, if you try to reuse an agent across different builds, across different projects, and here we have only one project, but in a real company, in a real usage, you have a lot of projects which are sharing the same environment. So what is arriving is that your environment is reused, and you may have some leftover, you may have some conflicts between the projects which are using your infrastructure. And when you build your project, this conflict could create a lot of instabilities. So here we just did a Spring Boot build, but with several executors in parallel. So we try to have the builds running in parallel. And we just, so it's working, but we have a lot of test failures. In fact, we have only test failures. We can see that everything is yellow. It's never working. And there are various reasons behind this. You will understand very quickly what is happening in such case. You have a file at the file system of the environment of the server. Here they are using the TMP Springlog file, which is used by the project. If you try to build the same project, you could imagine that you want to build several branches of Spring Boot, several feature branches of Spring Boot. If they are all trying to use the same file at the same moment on the same server, it is just failing. And if you try, because here we try to set up several users, real users on the server to do it, you have the conflict of access, permission access, and thus you cannot build your project. Thus, you have a lot of issues to try to optimize the allocation of your resources, and thus having a big server with a lot of executors, a unique agent and a lot of executors can be really difficult to maintain and to have really something reliable over the time, because you will have to manage all the potential conflicts you can have on this instance. And here, the issue and the error is easy to understand, but there are so many complex things which could happen. When you are using Apache Maven, but it must be the same with Gradle, you have the local cache of artifacts. If one project, if you use the same local cache of artifacts for all your builds, different projects, if one project is adding in your repository something which is not coming from the same source than another one, you may have a build failure for something you don't understand, but the artifact is also, yeah, but it's not the same one, because you build another branch of the same project, which is you are installing the version, and it's not the one which is the classical branch of the project. We had a problem, as an example, it's arriving to even the best ones. Apache Foundation, we know all of them, they are doing a lot of great stuff. They have a CI environment, a lot of builds, all the Apache project you can know. A few months ago, we started to have build failures randomly on different projects, and especially Maven ones, but we didn't understand what's wrong. It was not on, and we started to isolate. Okay, only some nodes, not all of them. They have those static agents with the shared nodes and so on. We finally discovered that one other project of the community was adding in the user land space, those in the user home, a configuration for Maven, limiting the memory, or I don't remember what it was exactly, but they were changing the local setup of the user. I know some customers, I had that in the past, not at CloudBees, in previous life, where a build was removing the .sh folder of the agent where it was running. The agent was then impossible to reconnect to the machine. So there are a lot of things in sharing this. The build environment is not easy. It's very difficult because you have to be confident in what others are doing, what they could do, and potentially a lot of things could be wrong. And diagnosing these issues is very difficult because you have to understand at the same time the projects which are involved on your platform, and you have to also understand the behavior of your CI environment, what is done behind the scene, and so on. So these are the kind of things that we see in a classical deployment with a lot of...
So basically what we were simulating here, just using the Spring Boot build as an example, is we had one agent on a, let's say, a beefy machine, which allowed us to have multiple executors, meaning they can do work in parallel. And that running things in parallel but not fully isolated from each other created here this kind of problem. And even if they were not run in parallel, it could still be a problem if things leave the state they leave behind is not how it was before.
This is what I reproduce in another use case, but I try to have those. I use another agent, but with only one executor. But the problem is that because there were some leftover between the build and so on, you had randomly some build errors because sometimes you were conflicting with the previous build and so on. That's the classical errors. And if you are in this situation, you completely lose the interest of the CI CD environment. If you are not sure that it is really reliable, it's useless. It's probably better to just delete it, just do it. So yes, it's really the kind of thing that we are seeing in a classical approach where you try to share the different resources you have.
Okay. So I think we have one more example to show, and then we want to go into how we can make things better.
Exactly.
Because so far we've shown what current problems we see, which is important to understand, how we can improve things. But so let's take a quick look at the Spring framework build, where we also use it as an example to show what we often see in practice. Right.
Those we reproduced. One more time, it's really a reproduction. It's not the real build they have, but we took an old build before you work with them of a Spring framework, and thus we reproduce a sequential build where we are checkouting the code, building it, doing some code checks with quality codes, check styles, these kind of things, and then executing the test. At that time, the build was taking more than 30 minutes. It was really a long build because each time was, for sure the checkout is quick, the 30 seconds, but then the build, 4 minutes, 5 minutes, not far, 8 minutes for the code checks, and then the tests are taking ages, 20 minutes.
Maybe also worth mentioning here that this is a different setup in that each stage runs in its own.
They are running they are running everything in this example. Everything is running in Docker. It's a small cluster, we will see, but here we are using for this project a small Kubernetes cluster on AWS, and it's really a cheap cluster. And we have this result. We are reusing the same agents in the same Docker image. We are running all these steps one by one. And we have this result, but we will see how we can improve that later using Gradle Enterprise and build cache and so on.
Great. So this build here, and I think we can go back. So this build does not suffer from things being left behind. Or
no,
but it still suffers from rebuilding all the time in each stage.
This is where there is always a trade-off to do, and there is always a decision to take. But using containers to handle the builds is very good because you have an isolated environment. You are starting from scratch. In our case, I just used an OpenJDK 8 or 8 version, and everything was automatically handled by the Gradle wrapper and doing the build. But it means that you are doing the checkout, you are downloading Gradle, you are downloading all the dependencies of the project, and then you are building the project, testing, and so on. This is the problem. Either you try to have a permanent environment for your agents, and then you have this problem of leftovers, of conflicts, and how to manage them. On the other side, you try to take agents, ephemeral agents that we call, and those general using Docker images. But there is an advantage. Here, I didn't do any customization. I'm not here for that. But I could have created, and I should have created as a build manager, a real image dedicated for this project. A real image where I provide by default Gradle, for sure, because it doesn't make sense to download it for every build. I should have maybe pre-filled a bit the local repository, because maybe a part of the dependencies which are not part of a Spring project doesn't make sense to be downloaded again and again from Maven Central or whatever. Thus, a lot of optimization can be done to have the right result in terms of speed without risking the reliability of the build. Because you control, and this is what is important. In fact, it is this ability to control the environment that you are using and to be sure that you don't have side effects of other things.
So it's again a balancing act between speed of building and the reliability of building. And we want to, of course, optimize that as much as we can and have fast builds, but still reliable builds. And we'll get to this in just a few minutes. Just one more effect I'd like to point out on slow feedback cycles, because it has more layers than one might think initially. So slow build times, it means of course longer CI runs. So you consume more resources per build.
That's also the cost.
That's the easy one,
It's just easy, this one.
But it's already expensive. But then also, typically when the build gets slow, the feedback cycle gets slow, developers start to run less locally, right? Meaning they're going to run more on CI, asking CI, is my change sound, right? So now you have again more load on CI. But there's another maybe hidden cost, and that is developers start to accumulate more changes as well, because even with CI, there's a wait time involved. So they want to accumulate as many changes so they don't have to wait for that feedback all the time. But that again makes it more likely that something goes wrong, because you just statistically, you make more changes, more likely something fails. And if that's the case, then it will also become harder to bisect the changes, because you have more changes that you committed, right? Which makes failure resolution slower. And also accumulating more changes, given the likelihood of a failure is higher, it again means you're going to need more CI runs until the build is green, right? So instead of doing that locally, you're using CI for your feedback cycles. And so if you then look at the sum of all this, you do a lot more runs on CI, which puts a lot more pressure on CI.
On CI and on people, because then you always have the same problem. You are in a bad loop, because you are consuming more on the CI side, on the hardware, but the people also, the stress created for the developers and for the teams who are involved to diagnose these problems, the time that they have to work on fixing the broken build instead of working on the real feature and so on, management pressure and so on. So, this is everything which is going wrong when you start to go in that bad side where, you stop to test locally, the famous skip test in Maven. When you start to do that, there is a problem.
But we could also say it in a positive way, and we'll get there, is if you have fast builds, right, you can build more locally. You can commit smaller changes, you get less likely that there's an error, and if there's an error, it's easier to fix, right? So that already shows where we're going, is that fast build times are definitely critical here and impact the whole feedback cycle in many ways, right? Not just slow, fast build, faster CI run, there are all the other paths as well here. So let's do another poll here. We talked a lot about pain points, and now we want to switch to how can we smoothen those pain points. What are your current pain points in your build? We give you a few options. Maybe you have other ones, but these are the ones we see quite a bit. So long time to verify changes locally. Let's say make a change as a developer, you want to know if that is a good change. So that takes a long time. Or you have slow feedback from CI, right? Or your builds are unreliable and flaky. Unreliable means you stop losing, or you start losing trust in the build,
Yes.
or you stop running the build because you're not sure. You start devaluing the feedback you get, or maybe there's something else, right? And then it's about time that we start looking at how can we fix the situation, because we definitely can, right?
We can.
We also see this in the projects where we help with, which in the end is not just bringing in or making the builds faster and more reliable. It's also how the pipeline is set up on Jenkins typically, but also if it's TeamCity or Bamboo. So there are ways to mitigate or really turn this into a good situation where people are happy. Right. Okay. So what do we see here? Current build pain points. And again, you can have selected multiple options. Build takes a long time to verify changes locally. That's 60%. Right. So this means developers wait too long to get feedback with all the consequences that we showed on the previous slide. Slow feedback from CI, 34%. Builds are unreliable, 32%, and 26 have other pain points. Right. I'd be curious to read what those are. Yeah. Okay, so let's proceed. So what do we want to achieve? Right, let's leave the kind of the dark world behind and see where we can go, because it's absolutely feasible. So what we want is fast builds, but we also want reliable or fast feedback, but we also want reliable feedback that we can trust, right? When things are built on CI, but of course it also applies to local builds. And that implies we want to have fast and reliable Maven or Gradle builds. And there we can help with Gradle Enterprise. We also want to have fast and reliable CI environment. Like we talked about what belongs to the CI environment, and that's where also CloudBees core can help. Right. We also want to have quick failure resolution, because even if you have fast and reliable builds, things will go wrong, maybe for good reasons. If a service is not available, well, then that can happen. But if something like this happens, or even something more tricky, we want to be in a situation where we can quickly solve that problem, right? And the goal there is, or it starts with understanding what happened in your build, or your pipeline. If you don't know what happened, you don't have the insights, there's no way you can solve this efficiently. You can only have gut feelings, you can have a hypothesis, and even worse, you cannot make then an improvement and measure again, because, well, you can, what you measure, you have no data, right? So we want to have quick failure resolution, and we need the data for that. Right? So these are some of the goals we want to achieve. So again, we will split it in how can Gradle Enterprise help you and how can CloudBees and Core help you here. So I want to give you some demos here on how Gradle Enterprise can help you elevate your developer productivity. So I mentioned how Gradle Enterprise fundamentally works with instrumenting your builds. So you get developer builds, CI builds, we capture data, we store it on the server, and we visualize that data. And it's very rich, it's very structured, it's very deep, and it really allows you to understand things to a degree where you can actually take actions and improve things and measure again. Right. And with these are the insights you get from build scans. We can also accelerate the build with Gradle Enterprise, which means you get faster feedback cycles. And that's where the build cache comes into play. And yeah, we go into it in more details, but the fundamental idea is let's not execute a goal or a task if we've done exactly that work before. Let's just use the output from the cache. And there's another thing we're working on, and that's going to come in the next quarter, which is when things have changed and we need to run tests, because the tests have changed or the class path of the tests has changed, we can run these tests distributed across multiple agents. And we're going to give a demo on that as well. Right? So again, we come back to running things in parallel. It's one of the most powerful ways to speed up the build of your project. And we can also aggregate that information that we capture. And through that aggregation and seeing what happens over time, we can see trends. We can see, are we still as fast as we got to the optimizations, or are we degrading, and so on, or aggregate data about what is the most common failure, and so on. And we'll see that in practice right now. Right, so let me start with the build scan side, which to summarize, it captures data about what happened in the build, and then you can make informed decisions what to improve. Right? And the other aspect that we're not going to go too deeply into, but it's because, and it might not be obvious, so I want to still mention it here, is via the build scans you can very efficiently collaborate with colleagues. Right? If you run a build on CI and it's failing, and you look at the scan and it gives you some details, and you realize, well, I now know what happened, but I'm at my limits. I need somebody else's help who knows more about this. Right? Maybe I want to come to you and ask for your help. I can just scare such a build scan that we'll see, and we can collaborate efficiently on it. Right? Okay, so let me show that in action. So what I have opened here is such a build scan. It's for the Spring Framework build, to come back to that example. And I also feel comfortable using the Spring Framework build because we did a lot of optimization. So it's not that this build stayed at 60 minutes, we got it down quite a bit via collaboration with the Spring people, but this is the state we had initially. But that's what you start with. You look at what's happening in your build, and once you know where the time is spent, you can start optimizing. Right? And just to give you a few impressions, idea of what's happening, we can find out information about in what infrastructure was this build run, with how many cores or how many workers was it run, how many cores were available, right? How much memory did I assign? These are all probably questions you would ask me if I say the build failed and I don't know what to do. Right? It's like, where did you run it? Things like switches, like what Gradle switches did you have? And what I'm showing here for Gradle build, for Maven, it's exactly the same. We have a Maven build scan, you see the switches, you see the infrastructure, right? So it's exactly the same way. In that sense. And what we can then, for example, already see here is that for every build they were refreshing the dependencies, right? Which means downloading the dependencies again. And that's a very expensive operation, right? But it's instantly visible here, and somebody that has the right angle to look at it will see these things, right? Of course, we can see what plugins were applied in what versions. We can see very powerful insights on dependencies. And dependencies are a tricky topic with transitive dependencies, conflict resolution, and so on. So it's all available here, and you can, wherever you are, you can search, you can link to it. I can ask you why is a certain dependency being used. I just point to it via a link, and you can work on it. Right? Insights on tests, and so on. But the one I want to go into a little bit more, because it's related to making your builds faster, is first understanding where is time spent. Right, and that's what we can see here. On 16 minutes and 15 seconds build time, 15 minutes are spent executing tasks. Right? And we can see a breakdown here. It's just nothing's cacheable, nothing was able to use the incremental build because they throw about the agent after each build. And so we end up with this time. And by the way, this now, since Spring uses Gradle Enterprise in production, this is actually a scan of a build they ran in their environment, right? So we're switching a bit between our own environment, theirs. Right? Okay, so that is, I think I'll leave it at that. That's just one I want to give you an impression in terms of where is time, what do build scans give you in terms of insight, right? But then there's also the aspect of aggregation. So here I can see all the CI builds for the Spring project and any Spring sub-project that were run by a user called Bamboo, which is the user they use on Spring, right? And I can see for a certain time period, so they were running 476 builds since we started this about 4 months ago, or 3 months ago, right? On CI, right? So here, and then I can start asking questions. I could, for example, say, well, how many builds did fail locally, right? So I can just say for this project, local builds, how many failed, right? And this might sound like a 217 builds. This might sound like a trivial question, but you could not answer that otherwise if you don't capture what happens on developers' machines.
We know that Andy fails the build 15 minutes ago. Hello, Andy.
Yes, exactly. And of course, the key is not to blame people this way or kind of expose them. But once you understand, and I know you were joking, but it's a good point because it sometimes comes up. Yeah. It's really once we understand what is going wrong, what people are doing, we can optimize things and fix those things Because if we see they're not running any tests, there must be a reason for it.
Exactly.
If it were the case, it's not the case.
And we can understand why maybe it could be also the local computer, which is slower than another. There are a lot of things. There is only by having this data that you can really understand why people are suffering and those why they are taking these decisions sometimes to do things. You need to have this information to be able to take the actions which will help the people. Yes. And for sure, we are not here to blame. It's really in the way to, if we understand what is going on, and those here on Gradle Enterprise, it will be the same with my product, but you can help. If you are blind, you are just blind. You do nothing, and people are complaining. And
then you start listening to those that scream the loudest, or you follow your gut feeling, but not the facts anymore. And we have other aggregates we use. So here I can say, well, for the last 4 weeks, for example, I can say, how did my build time trend? Like, did it go up? Did it go down? Because if we optimize the time, and we did, that's why it's so low here. We want to be sure it stays down, right, and not go up again, right. And there are other things we can look at also. For example, the dependency, how much time was spent downloading dependencies, and that would be really interesting to see with ephemeral builds, because there every time you need to get the dependencies again, right. So you can see what is the impact of that as well. We can also ask questions about failures. I can say, well, locally, what is the most common failure? Non-verification failure or verification failure, but typically non-verification failures are more relevant, more important to fix, right? So this is what opens up with these build scans. And then there's a last one on tests. Actually, I'll open that on a how do you say, developer version. So we're going to release 2019.5 next week. And once we do that, we will also have support not only for test insights, failures, and passing, but also for flaky tests. And I'm sure if we did a poll who has flaky tests, we would get a 100% hit rate if people are honest that they have flaky tests. Right? We do them. We have them as well. Right?
Which is one of the things the most difficult to fix. It's really difficult. As soon as you have flaky tests, you have to understand them. What are the conditions to produce the errors? And if you don't understand, and by having this vision of where it ran, what are the conditions where it's failing, you can try to understand. Otherwise, it's a nightmare.
Yep. Yes. And also, when you have flaky tests, it's hard to quantify how many times is it flaky. Which one is more flaky? Because which one are you going to fix first? You cannot fix all at once. Yeah. So which one you fix first? It's the one that's most occurring. It's breaking the most builds. And so going here, and of course I'm able to further break this down or narrow it down to a project, to a certain builds. I can, for example, see that in our project here, it was this performance build cache browser test that is the most flaky. Right? 7 out of 9 times it was flaky. Right, so now that I know this is the most common flaky test, well, let's fix it. And then we can measure again in a week and see which one becomes the next hotspot. Well, yes, so this is all possible because we catch a lot of data about every build you run, CI or local. Okay, then the build caching. Right? So build caching in Gradle means, or in Gradle Enterprise means, whenever you're on a task or a goal in Maven, before you run it, we look at the inputs, and if the inputs are the same that were used in the previous run, we'll just take the output of that previous run instead of rebuilding or rerunning that task or goal. Right, so let's not do any work that we've done before. Right? And the concept is simple, but the effect is huge. Concrete example, if we have a compile task or a test task or Maven or a compile goal or a test goal, what are the inputs? Different things, source file, compiler, compile class path, Java version, and so on. Right? And if those are the same, and we did compile before the classes, we can take them out of the cache. Right? So that's the concept. And it comes out of the box for many different tasks and goals. Some goals, it makes no sense to do it. It's like a clean. There's not much to cache when there's clean, but otherwise it is. Right? So I just want to finish off that part about Gradle Enterprise build scans and build caching. I want to give you an example. And that is, if you just turn on the cache, it's very likely that you don't get the full cache hit rate that you expect. Why? Because what we see is that oftentimes there are volatile inputs, meaning you run the build twice, you don't change anything, but the inputs are different. And typically it's timestamps or it's an absolute path that is different if you run it on different locations, different CI agents, CI and local, and so on. And that is a tricky problem to identify what is changing if you don't have a tool. And that's where we can help as well. Right? So let me briefly show that using here a build scan comparison. So I'm basically selecting two builds, I'm opening them up, and it tells me which tasks were different in their inputs. And different inputs means it wasn't able to use the cache. Right? And then we can see, the config properties were different. We're not capturing the actual values. It could be sensitive, especially when it's a public instance, like here. But we know something is different. And knowing that is 80% of having the problem solved, right? Because you understand what the task does, you look at the properties, and it's solved. Right? So that is one example. Another example is, and that's a pretty interesting one. So we were running some experiments to see, is it everything from the cache? And we saw, Kotlin compile had a difference, even though you just ran it twice in a row.
Yeah.
Actually, we ran it once on CI and once locally. And what turned out to be the issue is that there was a problem with that library in Maven Central, and so they replaced it with another version. And between the CI build and the local build, that version changed. And so even though it looks like it's the same version, actually the content was different, right? And if you don't have a tool telling you this, I mean, who would think of, I mean, we didn't think of it neither, even once we saw this. But once you know, okay, there is a difference, and so it puts you on the right path to find out what's actually going on, right? So very nasty problem but it's reality. These things happen.
Yes, and because you have a lot of things that you generally don't control, because even with those changes, because Maven Central is supposed to never change. When something is pushed, you never touch to it. But in my life, I saw some cases where, because of the order of your repositories, if you don't use a proxy, for example, next to HDFrog Artifactory, you can try to touch to various repositories and get the binaries. And if one of them is serving a different version, like here, of an artifact, and depending of the wine or whatever, you are getting the different one. Yes, you don't. And here you have the cache which is not working. Okay, it's a problem. But sometimes you also the behavior which is changing, because the library is doing something wrong, it's breaking things, and those impacts are very big. And to discover this, it's almost impossible if you don't have the traceability and the understanding of what changed between the builds and so on. So that's why it's important to track this over the time and to be able to understand.
Yep, exactly. And then I have one last example. It's one from Maven builds, right? So here you see two Maven builds from an open source project called Yukon. It's for like conference, organizing your schedule for a conference. And what we saw there, we ran compilation twice, and we saw a different in GitHub properties file, which for some reason ends up on the classes path, or in the classes folder, which ends up on the class path for compilation. And it turned out, okay, there's a Maven plugin that creates this Git properties file, and every time you run it, it adds or updates the timestamp.
Yes, exactly.
Right? So even though you don't change anything in your build, there's a plugin that changes something that becomes an input of a goal or a task, in this case a goal. And that then means it breaks the cacheability.
Even the manifest in the jar and these kind of things could have a timestamp which is changing over the time. And the Maven project is working on that to improve the fact that we want to have reproducible builds, and to ensure that when you take the same sources, the same project, you should have the same output.
Yes.
So Hervé Boutemi is working on that currently, and he's doing a lot of work, but it's not easy. It's not easy for sure. I suppose it's the same on Gradle side, and it's difficult to be sure that you don't inject. For example, this Git properties is well known because Spring Boot is something that they are using regularly to inject in your Spring Boot application your information about, okay, it was built with this SHA-1. But yes, if you start to inject the current timestamp, yes, you cannot cache anything.
Then and that's where the tool helps you quickly identify what's going on. And that's, like I said, is 80-90% of solving the problem, is understanding where it is. And so to finish this off, I would just like to show that once we did optimize the Spring Framework build with the help of Andy Wilkinson from the Spring Boot project, I was running this build this morning locally, so you can see local, and it ran in 23 seconds. And that's because I just checked it out. I had nothing in my local cache. I had nothing modified locally. So I just ran it. I even ran it with clean just to make it extra clear that I'm not reusing anything. It was just pulling everything down from the cache. Even at the hotel, with probably not the best internet connection, it ended up just taking 23 seconds to build the Spring framework. Right, and that's where we ended up by enabling the caching, do the comparison, fixing the differences that are volatile inputs, and that's where we end up. Right. Okay. Right, and so there's one last thing, and then I'll pass over to you, and that is working on distributed test execution, like I mentioned before. And so for that, I have a short video that I can share. So what we see here. Like I said, we're working on, if you run a test task or a test goal, we want to distribute the execution of those tests to multiple agents. In this case, it's Jenkins agents that are then running a subset of all these tests, passing back the results to the main build. Right? It collects it and then it continues. But via the parallelization, we of course gain the speed up. And if you have a lot of agents available, right, then you can parallelize more and more your build. Right. Okay. So that is something that is coming in the following quarter. Right. All right. So with that, how can CloudBees Core elevate the developer productivity?
Yeah. So if we take now you really dig in what you presented inside the project, how we improve the build locally and so on. But what we saw at the beginning is that the problems are not only inside the project, they could be in the whole infrastructure. And what we can see is you have complex environments, a lot of teams, because we are taking the simple example of one project, one build and so on. It's easy, it's not the reality. In the reality, in companies, you have dozens, hundreds of thousands of developers running a lot of builds of many projects. What we propose with CloudBees Core, firstly, is to help to have an environment which is enterprise ready, so to provide everything in terms of security, in terms of scalability, which is provided by default in the product, so to centralize the management as much as you want, and to be able to scale and to provide the environment for the teams. To not log them, to be sure that you not reproduce this famous Jenkins style environment, so you can really scale and provide them one environment per team, and you can move them and so on easily. Those flexible deployments, all the power of Jenkins. We are building CloudBees Core on Jenkins LTS, which is maintained by the community, and we are adding these additional features on top of it. How it's working? In our environment, we have the notion of an operation center, which is in fact a master of masters. So if you use Jenkins, you have this master with all these agents and so on. But what we say is that, okay, if I have several masters, how do I manage them? How do I manage their plugins? How do I manage the security across all the masters and so on? So we have this notion of MetaMaster, this operation center, which is controlling everything. Is helping you to manage easily and to give the access to everyone. So it's flexible, you can add, remove, and manage the scalability of your environment on demand if you provide the platform which is handling it. It's not working. I was not on the. And those technically, what the environment is providing is that you can have, depending on your infrastructure, some agents that you will also be able to reuse and to share across your master. Because this is what we said at the beginning. If you have a static environment that you lock into your master and so on, it's not efficient. You are paying or reserving resources for projects which are sometimes not building. You don't have the same life cycle. And if you have a company which is worldwide, those you have people sleeping, people working, and so on. Those why not using the resources of the others who are there while the others are sleeping? Those, we are providing all of that to be sure that you can scale the Jenkins environment by itself, but also the resources in terms of agents and executors to be sure that you can automatically scale and use what is available for your platform.
Just curious there. So can you still kind of prioritize the agent to say my team should first get the agents when they need it versus another team?
You can manage the priorities, but you can also log those. You have different strategies. You can organize by master, or even inside a master, you can have the notion. You have the notion of folder. You can reserve them by team, for example, organize them by team or by project, whatever. And you can say this pool of agents are for this team, this one are for this ones, or I am sharing this one between this team, and this team because I know that they are not working at the same time. So you can work on that to, okay, you will distribute those. You manage on one side the pool of resources, agents you have, and you reserve, and then you distribute them to your teams. But it means we are still in such approach with permanent environments. Where, okay, you have a pool of resources that you sometimes can start on demand, but in general you have them, you have some servers and you use them. And what we can do on our side is also to use nowadays with the technologies of containers and with everything which is allowing you to scale automatically, like Kubernetes, those CloudBees on modern platforms that we are seeing in the demo is based on Kubernetes. With everything you saw, the master, or in fact there are two masters, but everything is hosting on Kubernetes, and thus you are automatically creating the new pods, creating the new masters, creating everything, and the agents are also provisioned on your cluster. So you just give the resource, you manage your cluster, your Kubernetes cluster, like you do for others usage in your company. But here you have your whole CI environment, and on demand you will be able to add the resources and add them. But it's working on classical environments. We are supporting with CloudBees core traditional platform also the notion of VMs, and like I demonstrated before, I was able to plug some classical agents. So you can also come back on the classical approach where you have some dedicated boxes, agents that you are reserving and using for your build, and you have the others which are coming from containers and so on. Advantages and pros and cons of both approaches, but you have reasons sometimes where, okay, you need to have a real box. Have a look at iOS developments. iOS developments, you need an Apple hardware. Thus, you need a box somewhere. You cannot put it in theory in a VM and these kind of things. Thus, you need a real server to host your build and these kind of things. Thus, yeah. Try to find those, yes, flexibility in terms of the different environments that you can target. Those we target also, we have Windows as agents and so on. Those you can do that. And for sure with the containers, if you can leverage the container technologies, it's more efficient because yes, you can on demand create these agents which are really configured for your usage. Those you can really, this is what is good because every project can propose his own environment. And while in the past, in the classical static agents approach, you have to, okay, how do I manage the different versions of Java, of Maven, of Gradle? Okay, you ask to Jenkins to install them, you pre-install them. There is all these problems to manage. With a container, okay, each team can provide its own image. They can say, okay, on my side, I am using Gradle 6. Okay, I have my image with Java, Gradle 6, maybe a few more stuff. And the other ones on Maven, okay, they have their own image. Yep. And you just provision that. And
you can still reuse the agents across these projects, right?
Yes, because
the isolation is in
because it's just the minimum which is required to build your project, but there is no leftover. You start the image and the container each time you do a build. So you start from a clean environment having just what you need, what you consider to need. And thus it's really important because yes, you don't have any conflict to manage with others. You can start many containers at the same time. If you have the resources on your cluster, you can start a lot of builds, and you don't have to worry about that. You don't have the limitation of the classical approach. And thus we support all the on-premise. We support the on-premise version for sure. Those different Kubernetes vendors are providing Rancher and others are providing an environment. So you can do that. You can just come back also on the bare metal environments. And we have cloud offers. You can also find on the marketplace on AWS, Microsoft, and I forgot one, Google. One. You can also find our product and automatically deploy them on this kind of platforms. So, depending of your need, depending of your constraints, we are not all the same. Companies have different needs, and yes, you have this.
All right, then let's do another demo. So we saw initially what we often see in projects, right? With the sequential builds, not isolated from each other. So show us a few things, maybe on the Spring framework? Then,
yes, we can show that. Those firstly, CloudBees Core, I was using previously the Jenkins version of the UI, but those in CloudBees Core, we have a more advanced also version, those where we are seeing by default this notion of teams. A team is a master, those you can isolate easily, and those we created two masters, one for each team, and those they are running their own builds and their own resources with their users and so on. And then you can navigate and find easily your different builds. Those we have all the details. This is based on Blue Ocean view and so on, but you can switch, you can search your pipelines. You imagine if you have a real instance, you have a lot of pipelines, so you can search for them, and you can see all their details. It's a dynamic. Those if you launch them, if I take those, we stop at the long one. I forgot where we.
This one we have not done all the ones.
Yeah. Those if we run this one, for example, which is those master of Spring Framework, those after the work you did with them to improve the build time with, we can those directly build the project several times, because here we are in a container approach. We spin up the number of builds environments we need and so on, and we can follow live the build. And we see that here. This is a small cluster, really a small cluster that I deployed on AWS. Which don't await a lot of resources, but while in the past we were at 30 minutes to build it on the same infrastructure, we are back at 4 minutes to build the project. And
so that came from. So this build we had the caching enabled, and we had already optimized the build.
Yes.
So it's the build for master. So
it's a build for master. Everything is using the cache and so on. But for sure, as we are in a container approach, and here I did the simplest approach to build. I just took a JDK image. There is nothing in it. So you have to check out the product, the build, the project. You have to download Gradle, which is probably what it is doing right now. If we open it, no, it's already done in fact. And so it is starting the daemon, and then it's doing the build and so on and so on. So it will take a few minutes. We won't wait to have it the result. But yes, it's how it's working, and those, yes, it's isolated. You don't have you don't have any risk of conflict with others and so on. You have your own demand, and that's really.
So we're not at the 23 seconds that I saw locally, because we're running this in a Docker environment, meaning it has to download for each build the way it's currently done, because we didn't prepare an image that has this installed. You have to download the code, download Gradle, download
the image is empty. This one is OpenJDK. So you are downloading all the dependencies you need for the project. All these tasks are taking time for sure, and it's a really small cluster with really few resources. So that's why it's you don't reach the 30 seconds, but we can do the 30 seconds. What I wanted to share is.
So basically here what we see is all the time is the overhead to prepare the environment.
Yes, and this is a trade-off of you want to start from something which is always clean and thus reliable. And thus, yes, you have some time to prepare, you need some time to prepare this image to do the work. Or you prefer to start from an environment which has a lot of things, but you don't really control what there is, and you have a lot of risk of not being reliable. And that's why you have to find the right trade-off. Containers are really a nice approach, but it's not, you won't do that. You won't use OpenJDK image. You will build your own image with what you need in it to be sure that, okay, you are doing what is useful for your project.
Maybe you can still show that briefly. What if we assume the build leaves nothing bad behind, and we can just reuse using a static agent?
Yeah, we can do that, because here we have those. I did the same for Spring Boot, but the same build, but running on a static agent, which is a bigger box than the cluster itself. In fact, the build agents. The cost of the build agent that I added to this cluster is as expensive than the cluster itself. That's why it's a big server and so on. And in such kind of case, we can see that, yes, we are taking really few times 30 seconds, and we can see that we are leveraging the build cache that you are producing we can see here. This is the master. This is really the build of today. We saw Jürgen committing this afternoon and triggering a build. But we see that the cache is in place, updated by the CI of Spring.
Yep.
And those on our side, we are automatically reusing what there is. And here, for sure, it's very quick because it's a static agent. I reserved an executor and so on. So for sure, I know that I won't have any conflict because it's the only project using it.
Yeah,
but
so it means we don't have to re-download Gradle. We don't have to check out the project except getting the diff.
It's just
and we don't have to start a Gradle daemon.
Exactly.
And then we have the full caching, so it's the best scenario.
It's the best scenario that you can have, and yes, those in few seconds you just update what you have, and you see 12 seconds to further build, and it's something.
Maybe just one more thing here.
Yeah.
So if the build didn't expect as we, or we just want to know more about it, we can click here and see the build scan
and you
again,
see the build scan. Yes, exactly.
Which then gives us the details.
Yes.
Is there a view in Jenkins that would also allow us to not having to go into this log view?
You can. It was just published yesterday by your team, and Zeus in the last version, it was already there. In fact, you can see the build scans with the pipeline jobs. There is a support for classical job, but the goal is here to use pipelines. We are using a lot of pipeline because it's more flexible. You can really leverage more the resources in Jenkins, which is really better. The pipeline job is very, very simple here. Allocating a job and different steps I can show just after. But then, yes, we just say, okay, record what build scans are done. And if we have a look at what it...
And that's what we see here then in the build scans. We see there were three
there are three steps, three Gradle executions.
Yep.
And those for each of them, we have access to the build cache. Build scan, sorry. Which is available. So we see local Linux master and so on. We see all the details that you shared previously.
Yes.
And with the information, those we can see here that we have a very powerful computer, 8 cores and so on and so on. Mm-hmm. If I have a look at the same in the AWS cluster, in the Kubernetes cluster, it will be really reduced in terms of resources. Those we have that, and those the code here is very simple. Just to show it very quickly. No, I cannot scan. I cannot increase. It's useless. Just selecting which agent I am using, and then I'm checkouting the code. I am calling Gradle. The new thing is the with Gradle keyword in the pipeline that was just added, which will automatically record your build scan. Yep. And those Gradle itself is using, because we configure it, it's using by default the cache. Mm-hmm. So that's how we configure it. We say to use the cache, it's how it was configured in Gradle, and then we record them automatically, and those we call the 3 steps, build it, do the code checks. Here we have the list of code, and test. Yeah. And we are starting from scratch. We are calling the clean. Those, at least we are sure on this shared environment that, okay, we try to remove the leftover things in the build, but yes, it cannot be perfect. Here we know, we are confident we are reserving this instance. But
cool. Great. So, the way I would summarize that aspect is that we have to find a balance between reliability and fast feedback. Yeah. We get the best reliability if we run in an isolated environment. Yes. We can still adapt to higher peaks and lows by using a dynamic setup where we can dynamically spin up these new pods. For example, if you run on Kubernetes. And if you have a build that is so optimized now, like the Spring Framework build, through the caching with Gradle Enterprise, what we see is through when you do a build in isolation, the overhead of, by default, if you don't optimize for that as well, is that the overhead of setting everything up, downloading what's needed, starts to dominate the build. Yes.
It's what is important on our side, just to finish, but there is Developtics, which is an additional product. It's a free, there is a free version for, this one. There is a free version which is available for, you are not connected. So there is a free version, but you won't see it right now. I forgot that. It will be too slow. which will give you the visibility on the whole CI environment. So on your side, we saw that you have a really deep detail on what is happening inside the build, all the details. But on our side, with DevOptics, what we show is really the whole CI/CD environment, and we can thus track this time and track the progression of the development and so on, really at the CI/CD level. And thus we can plug the different steps, the different pipelines, because here we have one job, it's easy. Right. But in a real environment, you have different pipelines, one for the build, one for the deployment, one for the test, integration test, blah, blah. And thus we can show all of that in the way that you are doing it with Gradle, but just to follow at a higher level. Thus you won't be able to know, okay, this is because of the compile cache. No, you don't have the detail, but you know what is the step which is taking a lot of time and why your teams are not efficient, because, okay, they are not releasing regularly, they are not delivering in production regularly and so on. And these are the kind of things. And there is another panel which is the performance in terms of hardware, of the number of nodes which are available and so on. So you can see also in terms of resources what is available on your infrastructure and what you can do with it.
Nice. Yes, that's so these tools are really complementing each other, right?
Yes, exactly. You have
you have the full view.
Yes, exactly. From the top to the bottom, you can really dig and understand where is the time spent and how to improve and to find what are the best way to improve the productivity. And sometimes it's nothing, but you have to know where it is, and only by having all this view you can do it. Yeah.
That's great. So we have data in build scans, we have data in DevOptics that together allow us to measure, to make a change, to improve, and to then measure again if that change improved the situation. Right? It's great to have both. All right. So then I think we can get to wrapping this up. All right. So how can we make our CI feedback cycles fast? Right, to summarize. Let's not build things if we have built them before. It's unnecessary. We can use a cache for that. Make everything in your builds and your pipeline parallelizable. Yeah. So if you write unit tests, you write integration tests, and you don't design them to be parallelizable, then you pay a penalty for it. So, or said positively, if you design them for that, then you can enjoy the parallelization on all levels.
Yes. And take care to correctly split them, the unit test, the integration test, and so on, because just they are not the same thing. They are not doing the same thing. And if you want to parallelize, it's a minimum. But also, if you want just to optimize your daily experience, yes, you don't need to run everything. And it's not because everything is JUnit today that everything is unit test. Just take care of that. It's really important to understand what are tests.
Right, so you can separate those nicely, and then you can get quicker feedback from the unit test and get a bit slower feedback from the integration test. Keep your external components close to CI, right? Instead of dragging all the dependencies in from Maven Central or where it is, and trying to have the resources or the external components more locally, right? Less I/O overhead or less latency from the network. And also react dynamically to spikes. If you know, we see that a lot, you're releasing, you have a lot more builds, you want to be able to then scale up dynamically and then scale down again. Right? We can also make our feedback cycles more reliable, right? Using fast and solid hardware, definitely one aspect. We see that also quite a bit. People use shaky hardware, and then whenever they have a problem, they're not sure, is it a problem in what they just did, or is it a problem in the underlying hardware?
It's not easy to select the right hardware, and probably every project and every usage is different, but you have to test and you have to tune and be sure to do the right choice. It's not because you will pay a lot that you will have the best performance, because builds sometimes are requiring CPU, some others memory, some others IOs. It really depends on what you do and what is your domain, and maybe different projects will have different needs. So that's why take care of that. Take the time to study and to understand what are the needs of the different projects.
Yes, very correct. And again, this can be done via measuring instead of speculating.
Yes.
Maximize the isolation between builds, in particular when you know the builds are leaving something behind. You will save yourself a lot of debugging time. Right? And ensure the external components are accessible also reliably, right? Because all these builds today that we run in CI, they rely on other components. If they're not reliable, then your whole pipeline, your build, your pipeline, everything is unreliable. And so how can you keep the costs low? Related to CI, but it also applies in general to local builds as well, is understand how your software is built, meaning measure, change, the right things and not based on speculations. Use fast and solid hardware, yes, because in the end, an AWS instance is going to cost you less than an engineering waiting because you want to save those hardware costs. Have fast and reliable builds. We talked about that in detail, the quick feedback and the feedback you can trust. And also allow developers to do as much locally as possible in a feasible time. Because that again means you need less infrastructure on CI, right, or less resources on CI. Yes, and I think we also agreed on that engineers in the end are your most expensive source of costs, and let's make sure they can work productively, so they don't waste time debugging or being idle. And instead invest that time into
they will provide more value, that's all. They will, if you give them the right tools to do their job, they will just be more efficient every day and provide more value, more releases, more frequently, more quickly, and so on.
Yes.
It's really, yes.
So you want to have fast builds, reliable builds, you want to have fast hardware, and so on. Right. So to summarize what we've been talking about, really Gradle Enterprise and CloudBees Core can highly increase your developer productivity when you use them together. Make people more productive and also make them more happy, less frustrated. And in the end, you will reduce the human costs as well as the hardware costs. Right. There's also a book that we wrote called Developer Productivity Engineering. If somebody needs a Christmas gift, you can get it for free and put it under the Christmas tree. I'm sure we can get you a signature from our CEO as well. But it's definitely, it captures the essence of the last 10 years of us doing, helping people with build automation. Right, so it's definitely a very substantial piece of information. So I think we're right on time with the 90 minutes, a little bit over, sorry about that. But if still people have some questions they want to ask or some feedback, we're happy to. And of course, Arnaud, thanks for coming all the way from France.
It was
actually was a trip for me as well, coming from Switzerland. But it's great that you took the time and do this with us here. All right, so I got the signal that we should stop here. We're on time. And we wish everybody a good day, good evening.
Thank you.
All right, thank you.
Thank you, everyone. Thank you again.
Bye.